Hello guys, welcome to yet another system programming tutorial. So today we are going to build a chip 8 emulator and actually play a live game in it. So the game we are going to play can be found inside this GitHub repository. These are chip 8 ROMs games. So any game that is available here, you'll be able to play inside our emulator. So I will leave a link to this GitHub so that you can test the code with all other games that are available. For the gameplay, as you can see, we are dropping bombs as our upper plane flies. We are able to drop bomb, and if we drop them on the flying planes, we get points. So I'm pressing on my keyboard, I'm pressing on digit 5. So to learn for the website, and also link it in the description below so that we're not wasting time. So let's jump onto our IDE and set everything up, and then see what this has for us. So I've scaffolded the Golang application here, and we have a makefile. This will just help us build, and let's see if it works. So rm, let's remove ch8 emulator and let's make build. Yeah, so I think that sorted our issue, and let's run. This works. So how are we going to go about this? So we are going to build this with SDL. So into our main file and start going. So we will need some constants, and this will be like our window tile, our window width, our window size, and then the game cycles per second. So let me input that. We will be loading external ROMs from this. So let me create a directory that will contain our ROMs. So we can, let's download the airplane one. It's here. Download raw file. Can see it there. So we will move it from our downloads. What you can do is rename it. .ch8. So yeah, we have that. That is the ROM that contains the game that we will be playing with our. So let's go back to build first. Let's remove that. Yeah, since we said that it will be taking a ROM, we can check for the os.args. If they are less than 2, we are going to log. So we will be using SDL for all the displays and all that. So we can initialize the Go SDL package. Let's just name it SDL so that it doesn't disappear when we are. When we save the file, disappears. So let's make sure we use it so that we are going to init it with SDL dot init everything. and then we check error not equal to nil. That is if everything we log this will be the gameplay window. So we'll have window and an error equals to from SDL dot create window, and then we are going to pass in our constants. So like window title, this one we defined here, and then window position we are going to have it as undefined, and then two of those, and window height. Then we are going to show the window. So SDL and that will be our window. So in the above we can have error if error not equal to nil. What will we do? We are going to log dot fatal and say something like could not create SDL window, and then we'll defer window.destroy. Let's just print fmt println rom path. Let's see if this works. Make build go mod tidy. Let's check what's going on. Oh yeah, we have an error here. Go run main.go. A ROM is required to run the simulator -- ROM So we are going to create the renderer. What will render the game? Just have that window, and then If the renderer is created, we defer renderer dot destroy. Yeah, these are this is a wrapper for SDL. If you've programmed SDL, you know these functions. So then we will set a scale mode for better pixel rendering. So what are we going to do? We are going to take the renderer, our created renderer, and set scale to it. We'll give it a 10 by 10. Then we'll need some key mappings, which I'm going to copy because writing them is tiring. So our chip 8 emulator code will go there. Then we will set our keyboard mappings for this. This is still just SDL stuff, and then we will create a main loop, our running loop, and then for handle game events. So yeah, so I want to explain this part of the code. So this is the heart of our emulator. The main loop will run continuously until we quit. It handles it will handle 4 main tasks. So processing user input, updating timers, executing the chip 8 instruction, and then rendering when the display changes. We use precise timing to maintain accurate emulation speed. So we are going to switch on the event type. We jump out of the loop. So the second case, what do we want to do? Let's just type here. For now. Yeah. Let's I don't know if println will print this E so that we are just using it. So if E dot type will be equals to SDL dot key down, what are we going to do if so we update the chip 8 timers. We are going to, I know we've not implemented this package, we're going to implement it soon. Then now again we will need to execute CPU cycles. At the specified rate. How do we do that? If since last CPU cycle time is greater or equal to cycle delay, we are going to call chip 8 dot cycle and set the last cycle time to now. Time dot now. Then we are going to render if the display then for good practice we are going to do an SDL dot delay and we are going to delay for 1 millisecond. This will prevent CPU hogging. So chip 8 going to be our chip from our chip 8 module dot new chip 8, and then if error equals to chip 8 dot, we're going to have a function to load the ROM, which we are going to give the ROM path error not equal to nil. We will make some noise. Log dot fatal could not initialize chip 8 and load provided ROM. Now into the juices, let's code up. We will need a new Go file, chip 8 dot go. So package chip 8 type it will be a structure, and so this will be the heart of our, this is our project, like this is our emulator. this will be our virtual machine here. So we are going to have some memory, which will be 4096 of type byte. Then we are going to have 16 general purpose registers. So in 16 we are going to have our program counter, the PC, and then we are going to have our stack, call stack. Then we'll have our stack pointer. Let's name it SP. It will be uint 8. And then delay timer. This will be our countdown timer. Then we'll have our sound timer. And then we'll have our display. And this one. What else do we need? We'll have our draw flag. So 4 kilobytes of RAM. Our programs will be loaded as 0x200, 16 data registers from V0 to VF, an address register I for memory operations, a program counter and a call stack, 2 timers that will decrement at 60 Hz, a 64 by 32 pixel monochrome display, keyboard state tracking. We'll have our keyboard state tracking and random number generator for games. So I'm going to copy a font set that we are going to use on this, and let me paste them there. So yeah, and then we are going to write our function, the new chip 8. So it will take nothing but will return a pointer to our struct. And what are we going to do here? So we are going to initialize our PC and then load the font set into our memory. So how are we going to do that? Let's initialize our, it will be a reference to chip 8. Our PC will start at 0x200. And then will be run.new, and run.new then we convert into Unix nano. Then we are going to load the font set into memory. So how do we do that? We range over there for I, comma B, no range 050 plus I. Then we are going to return C. If we go to our main file, we find that need to, now there is no error here. Now we need to do the load ROM and update timers, cycles, and we'll be done. So how do we load the ROM? Takes a path of type string and returns an error. So we can return nil here. Then let's implement key down and key up. We are going to update timers here and delay and sound timers like that. Here I'm going to set c.keys. This one will take a key of type uint 8 at key then the key up will do the opposite. Yeah, I'm only left with to implement the cycle. So let's see. So in our let's load the ROM first. Of ROM comma error equals to os dot read file. The provided path. If error not equal to nil, we'll return the error. Then we want to check if our ROM can fit inside the memory. So if the length of ROM is greater than, we had 40, 96 minus 0x 200, where it's starting. I think we can print a warning here and then try and load the ROM as it is. We can print that warning, and then we are going to take only the portion that can fit into the memory, and we try and put it inside the memory. And what are we going to, if everything is fine, we are going to load the entire ROM into memory. And then return nil. Now we are left with let's see now if it, let's see if it still compiles. Actually, it has no field size. I already wrote it, so we can and voila, it worked. So let me see if dropped a bomb. Missed. Dropped a bomb, missed. And that's it, guys. Please like, subscribe, and see you in the next video.